Everyone, please come back to your seat. I will get started anyway. I'm in a rush because I want to finish in time. But because I have to go on to do an online judge for Indian hackathon that's going on. That's why Alex is not here yet. He's still busy hiking for the last hour before they finish up by 12. So whoever wants to interested in the look at the hackathon results, you can come see it online. I will send you the pointer. Get to my talk. I'll give you a quick summary of the Indian community meeting that happened just 1 day ago, Thursday, Friday, at the Memphis. I think 1, 2, 3, 4, 5 people, maybe there already. So for you guys, you already know what happened. The day before Indian community meeting, we had a 1-day retreat. Some people asked whether they would sit in there, and I said probably not, because that's a totally internal. You can think about great progress in research, otherwise great fight about technical issues. We realized that almost 7 years, time passed really fast. But that's really an exciting journey. It's a great team. Especially look at the 7 years we've been together. As a big achievement on their own. And also, we have been following this one simple principle, application-driven architecture development. Because, following this quote here, that's always my motto. It says that experiment is the sole judge for scientific truth. That's what we've been doing for, in the end, try out all the different applications and see whether it actually works. So big chunk of the day, I can share this with you, is to discuss with Jeff Burke and his team about what they really want and how we can serve them best. Jeff keeps asking one question. Do I have to know anything about networking? And of course we said, no, your code doesn't have to worry about that. And we take care, whatever the need, we have to supply just for you. So therefore, yeah.
Could you close the mic because we're on remote participants?
Oh, we have
just for the record, you're citing Feynman, who's citing Galilei.
Okay, thanks for that. Thank you for that. So application is always, the top thing that drives all the other needs. We have been developing the new concept that's kind of replacing the point-to-point TCP connection as a transport. We call the distributed synchronization, because generally speaking, today's applications are distributed. So therefore, it's not so much one point send data to another point reliably, but rather among all the distributed collaboration sites, how you can synchronize the data in the most efficient and resilient way. We have put a lot more emphasis over the last couple of years on the wireless ad hoc mobility stuff, while continuing to address the scaling issues at a global scale. So one thing I forgot to mention, well, I haven't got there yet, I'll let you know. And we have also continuously put lots of emphasis on the security, especially usable security. Tools development, you will see some of that in the community meeting. And talk about the engaging community, we feel that we have been running the Indian community meeting, but definitely we need to do more to grow the community a lot faster. We also have good opportunities for doing that now. I'm going to mention that a little later. So this is, I try to give you the highlights of the community meeting, but this time Memphis is the host, and they did such a great job. For whoever there or whoever not there, you really missed the opportunity. The facility, the meeting room, was, I was told, I have not been there, I was told it's United Nations style. Yeah, it's a raised floors, and every single one got a mic. It's a brand new modern thing. I wish we had that at the way. So we started again using applications to opening up the meeting started with the sessions on the mobile IoT and challenging environments and data-intensive applications. So just for that, I want to mention a few things. This is the talks in the first session about mobile IoT and the challenging environments. There's something I think is really interesting. That is, the first talk is about low-rate communications basically for rooftop networking. They use LoRa, LoRa. This is actually the work done by a startup in the solar area. They funded by Department of Energy. They try to build this rooftop LoRa mesh network. They first looked at the IETF standard track. They felt that it's too much highway weight. And they did a Google search. And I would say, thank Google. Google pointed to NDN. So they sent us an email to say that we want to learn more about the NDN because that fit our application scenario. And then they flew down to LA to chat with us. And started from there, we started the collaboration. So they got the funding and they cut us a subcontract to help them build this rooftop wireless mesh network, purely on NDN. I think I sent a message earlier to the ICNRG mailing list to talk about constrained environments. This was a collaboration with them. Now they are open, so they said we can talk about that openly. They have a little tiny packet size. I don't remember. I think definitely below 100 bytes. I think it's 64 bytes. So I really says that, if you design the NDN protocol right, you can go as small as that, and you can go large as, I don't know, however big a protocol packet you want to make it.
Quick question is, so this solar setup, is that a mesh network?
They set up rooftop
Yes.
mesh wireless network.
Okay.
Yeah. So you can look at. No, LoRa is not mesh. They use LoRa as a communication, as the radio technology to build the mesh network.
So are the devices using LoRa amongst them, or is there a LoRa, gateway?
Among them, yeah. You can look it up. I should have put the company name there. It's called Operant Solar.
Okay.
Yeah, you can search on. You can find them directly. Yeah. So you can see that the other things also about opportunistic wireless networks. We made a further progress on the NDN implementation on Riot. When Alex got here, he might be able to give you more details on that. And there's one talk about opportunities for NDN in augmented reality. I want to say a few more words about that. So look at this picture. I think the new applications, exciting ones, are really coming. You might have seen this before. This picture before. So what's the difference, right? It's no longer just that you type a URL, go to somewhere and find information. What we are trying to build this thing, we're really going to work on this later this year. That is, we say that all this augmented reality or virtualized reality or combination of them all going to enhance the daily life. Other things I don't know well, but look at the UCLA campus. I've been there 20 plus years now. It's a gigantic place. There's so many things going on. You never know where things going on. What. So therefore, what we are seeing here is that augmented reality allows you to browse the campus. Now, what's the difference between browsing the campus versus you just type in, www.ucla.edu? Okay. Browsing the campus means it's augmented reality. You can just say that, with your phone, you want to know about the campus information. The data, as we've shown here, actually comes from all the sources. It's not from a single particular website, but instead, based on your interest, your context, then you can really collect all the information from different sources through all the different heterogeneous wireless channels and get assembled together in a comprehensive way on your screen, on your phones, when you're moving around, going through things. So I think we heard earlier about combine the use of the LTEs and the Wi-Fi's. And on top of that, we're also going to do, Bluetooth, Wi-Fi direct, Wi-Fi ad hoc, so that you have very rich, richly connected local edge computation environment and get whatever information you needed. One thing that didn't show up here is that we also actually going to work together with people who are doing computations to move the processing to the edge. And with the ICN technology, where you just request data by name, you don't really know or care where the data comes from. It can come from the network, can come from nearby storage, or otherwise coming from computation. In particular, with one professor called Jason Kang, he's an expert in this area called domain-specific computing. Effectively, they use programmable FPGAs to install specific computation functionalities into the chipset, so that you can really bring this augmented reality and virtual reality down from the cloud to the edges, and really benefited through this approach of browsing the campus. And eventually, people will talk about smart cities. You can do the same thing about browsing the cities, but not limited to a particular web server that give you whatever information it wanted to give you. We're really talking about now many communications, and thanks to the technology, we can do it now. So now the challenge is really up to the architecture, the protocol stack, how we can utilize all this information to bring life into a more exciting next stage. Security has always been on top of our things, but people are still pushing us. I'm going to tell you a little more later. And then I want to say that we focus on the tools development. So there's particularly two things about Indian Control Center. It's basically before use of the code a little challenging, especially for people like me who has not touched the code for ever since I joined UCLA. And so this allows you to, the NDNCC, otherwise Indian Android, would allow you to just install the whole thing and run the whole thing with couple button pushes. And this time we're putting the Wi-Fi ad hoc into the NDNCC and the Wi-Fi direct into the Android. Why don't we do Wi-Fi direct? No, why don't we do ad hoc the same way for the Android? Because Android doesn't support it, as far as I understand, without using the phone, which we feel that many users don't want to do that. The additional sessions, including the applications, routing and the forwarding, there's some more interesting stuff about routing. Is a new thing called geo-hyperbolic routing. It used to be that there's a hyperbolic routing. You probably have heard a number of times that's been going on. But the recent progress is really adding geolocation information that improves the result in a big fundamental ways. There's some new work about loop-free multipass routing and other things. One thing I forgot to mention is that I'm going to send the slides to Dave when I finish here. If you follow the community meeting website, that actually has pointers to the recordings. Talk about the advanced facilities. They actually real-time streamed the whole meeting as well as recorded this. So you can go there, browse through whatever the things you want to mention. You are interested. I think that there are two panels. The earlier thing about security, that's actually a panel with a couple of fellows from Verizon joined the panel together with Jay. I think Jay is still here. Alex Haldeman, who's a professor at the University of Michigan. He's super busy these days because he got involved with the presidential election security issues. So he went to the Congress and whatever things, but he was in the panel and really gave lots of great comments. And the second panel I want to point it out is this NDN at the edge and on the horizon panel. Look at it's part of the panel. Well, it's still here. I would also like to see if people would be interested to watch through that. I thought we brought up lots of interesting things. In particular, Jeff Burke was the panel chair. He really tortured us by asking very, very tough questions. I think you would agree with me on that one. So that might be interesting to watch. I think I'm running out of my time. Let's talk about this. So we always, at the Indian community meeting, we'll go to a round table, collecting the feedback. This time, the good thing is, like I said, everyone has a mic, so that you no longer have to pass the mic around and give to the next person to speak. And I really enjoyed the facility tremendously. But we run out of time to let everyone have a few minutes to talk, because we scheduled 1 hour. I think the last 1 hour and a half, Lan Wang, who's the chair, just simply cut it off. So then we received some emails for those people who didn't get a chance to express their views. So there's one message I found out in my email box and talking about, of course, they thank us for inviting them to join the meeting, but look at the couple of feedbacks this fellow provided. Is that, can we expect expand more research and technology development on Indian security? I think security, to my personal view, is really the fundamental points, one of the fundamental points, the advantages of ICN. I think that ICNRG, of course, covered many grounds, but maybe I would make a suggestion to bring up the attention to security by a notch, because that's really, really important now. Especially for security, if you don't start from day zero, it's very difficult to.
So I was going to ask you if you would drill into, like, what do you mean when you say security? Will you tell us?
Well, we have been building applications, and we admitted in this paper we published in 2015. It's about the schematizing trust in Indian, where we admitted that when students build applications, the very first shortcut they do is ignorance of security. Fill in the signature by whatever junks they can figure it out, and say, well, we'll take care of security later. So that basics tells us that they're not intentionally not lacking the security, but clearly the use of it is really difficult. How do you figure out, first of all, what does security means? Security, the first requirement, you have to have identity. Then you have to have certificate. Where do you get that? How much effort it will take for you to get that? And once you have your certificate, NDN or ICN in general allows you to have a highly granular security. That is, you do not use your personal certificate to sign everything you produce. Instead, you're going to further produce, the separate certificate, one for each different applications, so that this will give you the resiliency. When one key gets compromised, you don't lose all. And also, you have access, other people have access to one part of your data do not have access to other parts of the thing. So this is all the security people told us. I was trying to count how many years back. There's a very famous paper by Jerry Sauter, who's my advisor's advisor, and another person talk about, it's one in the Maltex days. They wrote down about the principles of security. And I think one of them is list the privilege, to say that one must limit the privilege of the individual authority or authorized actions, right? So, but so far I know so little about security, I feel a little embarrassed to tell you anything about security. But the fact is, everyone knows, right? The TLS, that's as a granularity as you have today. you set up a connection, and everything goes into that connection is so-called security by that key. Right? You go to a website, and everything's secured by that single website key. That's it. You trust that key, then everything goes. So what we have been doing by watching how the security first get ignored is to recognize the use of security is difficult, and then you have to really develop the tools to make it usable and useful. So first of all, you have to, this is the research. We really started building a certificate system. So for people who need security, can get it. Of course, this requires verification, authentication, and authorization. You get a certificate. In particular, for the test bed, there's an issue. On the one hand, you want the test bed to be open for everybody to use, not just for the Indian team members, but for other interested parties. At the same time, you do not want to just move away from the security. So there's a lot of questions we basically face on a daily basis. We have to address them. And then along the way, we build the tools to do it, like for getting the certificate issuing, the data signing, data verification, how you can make those things more automated so that application developers no longer have to worry about that. And that requires that we started from the trust schema. It fundamentally says, hey, now we have names, and names are semantically meaningful. So therefore, all the trust policies can be defined by the relation between the key names or certificate names and the data names. And so therefore, as the application developers, you don't have to be a crypto expert, but instead you understand, right, what's the security policy for your application, who should have access and who should not. And then system will help you to express your policies by using this some kind of limited expression. We use a regular expression and got beaten down by Van. That's too liberal. It's not restricted enough. So we're doing the modifications on top of that. And the students working with professors actually in the language verification to see how we can actually formalize the verification of the trust policy using a schema to make sure that there's no security holes. But that's a little too much advancement topic. But I want to say that, this is a community feedback that we have been putting lots of effort into security, but we're not doing enough. And the second point this person makes is that they want to have the Indian to be on more platforms. So we'll take those into consideration. But it's also making the point that, if you want to design something for the future, you really need the community feedback. And together, like Luca already did, that we need community contributions. So we were currently working on some kind of contribution guide to provide so that when people who want to join the effort, they can figure out exactly how they can chip in and what are the things, where are the resources we could depend on. And I also want to tell you, there's a little advertisement on myself. So we're going to host a SIGCOM at the UCLA during that later part of August. And we'll have an Indian tutorial. And I hope people will come to UCLA and enjoy our modern facility. And UCLA just put up a new conference center. That's how we were able to host the conference on campus. It's just about across the street, maybe from here to here, little few steps off to the computer science building. That's how convenient it will be. Hope to see people there. So I talked earlier about to say the really new opportunities coming. Earlier we learned about the NSF-Intel partnership on the ICN wireless edge. We'll miss Eve's talk on Thursday, but I'm eager to hear that. But more recently, I marked down the date, it's January, DARPA also took action. They announced the new program called SHARE, Secure Handhelds on Assured Resilient Networks at the tactical edge. I will not read the solicitation details, but I just mentioned that in the solicitation, they mentioned in a few places, spelled out specifically that today's approach to security, especially in tactical fields, does not work because the high dynamics, high loss rates, and other things. So therefore, they called out specifically to say that people should look into name the data networking developed under the NSF sponsorship to build this future resilient, the tactical networking solutions. This is the end. I think the 2017 has had a great start. The ICNRG and the SHARE programs really have brought the word about NDN and ICN more general to the broader community. Once after the SHARE solicitation went out, for many people, they heard about NDN the first time. And you know the result is that we got flooded with all the requests for collaboration. And we realized how little the Indian team can do. And so therefore, we really call out to the broader community for collaboration. I think that the ICN program, ICN1 program is really a great step forward. You know, what happens as a result is that in putting the proposal together, so Indian team individuals actually worked with other people. Then we really at least we broadened the current participation. Like for the UCLA proposal team, it's not just me and Jeff. In addition, we grabbed this 4 more other faculty members into the proposal team. So they now understand NDN, and now they will be working on NDN. So we didn't do as well as the other teams, other proposal teams. Professor Patrick Crowley, he worked with yet another proposal team into the program. He actually educated 8 other faculty members in multiple campuses about how NDN works. Patrick told me actually, he was saying that, you know, the idea is just like something, it's catching the fire. He didn't have to say much. And people just grab the idea instantly, they understand it. Because those people have been facing the challenges in doing the wireless over the TCP/IP for years. So therefore, once Patrick explained them the idea, they just got it. So I credited him. I said, you know, you really spread the words. And he said, I didn't have to do much because the concept is so intuitive and people understand really well. Anyway, I'm over my time, but I want to say that we really have a good start. And I think that having the ICN from edge in has a great potential that we have been seeing lately. And with the Cisco's effort removing the IPR barrier, we're really looking forward to a very productive years for the ICNRG. Thank you very much.
Thank you, Licia. Any questions, comments? Okay. The next is Prakasha. Oh, sorry. Yeah.
Yeah. So, and when we did the analysis for this, there is almost about 60 plus invalid messages over the client and network before even you can get to the IP addresses because you can just start and do the data. So the work what I'm going to highlight is that 2.1 is how to cut down the number of messages and then the two is that how to avoid the overlay so that you can easily get the data. And then we did some analysis on type of overlay. But if you get this is a DCRS analysis program, that creates an overlap of around 60%. So 10 to 18% based upon your packet size. And if you use IETF on top of that, then it's 20%. So there's a lot of work and remote. In the whole, is that is there anything you can reduce this overlay so that you can really take the benefit of this ICN protocol. We will go to the next slide. So what we are proposing here is that this is again very high level. When we see on the active left side is user time should be consumer or can be supported from that perspective. And what you see here are the two or three elements we have here a radio for technology, we have a FDP, which is points of attachment for all the mobile devices, and we have IETF, but the entry point for maintaining the mobility segment from the time the device connects to the channel that the device is there in the network. So what we would like to suggest is that this is here on the extreme left side where we have become in action. That's where the ICN interim comes up. So that's where we plug into that. And we want to introduce a forwarding agent. And this forwarding agent, in my opinion, will provide the ability of making the decision about which type of transport you want to use. Like maybe based upon the cost, based upon the convenience, based upon the business preference. That might have been cheaper in the night, versus more expensive in the daytime, or so based upon the location. So that, in my opinion, is a research area. And then what we want to do is that when you see the IT set, you can introduce a ICN function there. And correspondingly, you have to make the place in the CCW, like in the content, and like that. And I have provided a lot of discussion about something called
Thank you. Yeah, that's why I was asking because I was not able to hear my echo. Okay, thank you. So if you can go to the next slide, and if you want, I can repeat that again. So this one is very interesting, and I want to relate it back few years back when IPv6 was introduced, and I always look from that perspective that hey, what really changed in the mobile network when IPv6 was introduced, because everyone was quite happy with the IPv4 and they ran into the problem. From our analysis, when we want to introduce ICN or name-based networking, I think it is more or less same problem what we went through when IPv6 was introduced. So if we relate from that point of view, the client has to be identified either as an Indian client to really take the benefit of removing this overlay, what we just described earlier. So, and I have worked on the area how we can introduce the client identification. So what you see here, there are two different options. The option on the left side, you can call it a dual stack or triple stack. When V6 was introduced, we started calling the handset as a dual stack if you support V4 and V6. What we can do is that when we want to introduce ICN, either by using the embedded, we can embed the NDN or ICN name address inside the IPv6 header, or we can create an additional protocol version where the client is identified natively as the ICN itself. So what you see here, the forwarding agent that I described earlier, that it can have the intelligence to to bring the information from transport point of view about which transport is preferable from the cost, location, congestion, QoS, each of these criteria. And from top, in terms of the application's preference or the content's preference, that I want to get the content either receive it or publish it using NDN versus IP versus different options. And then the client's capability could be introduced in terms of two additional sub-function, which could be the ICN function or which could be the existing IP function. What it will require is that the moment we want to introduce this function, we need to modify the lower layer, which we call a PDCP layer, because that layer has an intelligence about the physical part from the MAC layer, and it has an intelligence coming from the content point of view. So that will be the changes required for the dual stack or triple stack client. On the right side is the native implementation, where the client does not have the capability or it want to be only the native NDN client or ICN client. So when we described about IoT type of devices, they may or may not need to be IP aware. And those clients could be just the ICN aware clients where we don't need the IP and they could be attached using that. So if you can go to the next slide. So that was the part in the client. Now if you want to introduce in the base station or the first point where the device get wirelessly connected, what we can do is that again we see the protocol stack. So I want to relate it to the point number 102 and 103. So point number 102 is when client made a request that I want to be a ICN, and when that request comes to the base station, how this has to be handled. And especially in the case when the uplink from the base station is various types. This could be the IP, this could be the IPv4 v6, this could be the ICN based, or this could be the dual stack. So each of these logics, when it comes at the base station, this could process that, and then it could send it out upward towards the PGW or SGW in terms of based on the transport. So if you can go to the next slide. So here is what happened. If the client comes and make a request that I am a native ICN client, that is how I want to be attached, and that is how I want to send the data. And assuming that if the transport is available as ICN only, then it can send it to that. And in second scenario, if the client is identified and making a request as an IP client, and if the IP transport is available, you can send it using the IP transport. And in the third part is that if the client is identified as dual stakes, so if there are two type of attach request that the client is making, and which is not unusual, because I'm not sure how much you are aware, but this phone what we have, it has multiple IP addresses, not just one. Sometimes if you see a complex phone, you might have more than 8 IP addresses, and that is based upon type of devices which are being attaching. And imagine about the complexities when you have 8 different IP addresses, which application will take what IP address. There is a complex algorithms involved in that. So imagine that some of the devices, if they are being requesting an attachment with the ICN, IPv4, IPv6, then we need to build the logics inside the base station when this request comes, how to deal with that. So that goes to the third part for native IP and ICN. You can go to the next slide. So let me quickly walk through, and I had a very lengthy discussion with our team and our colleagues who are working with 3GPP, because in my opinion, we can discuss about overlay implementation on ICN, and that's fine. But if we really want to take the benefit of native implementation in the mobility protocol, we have to work with the standard bodies like 3GPP or because that's where it will go into the specifications. So what you see on the right hand side is pretty complex diagram, but I want to make it very easy. The first point is that when when the device want to attach to the mobile network, it has some way to tell to the network what type of client I am. And there is a field defined which we call a PCO, which call a protocol conversion option, IE, and in that PCO IE, you can define with the ICN based identity, or you can define like a dual stack or triple stack based identity. So what you see here top on the message number 1, which is the attach request, that's when the client getting powered up and is trying to attach to the network. We can put this this PCOIE field into that, and that will go into the network, and rest of the messaging may not change, but those interim devices has to be fully aware of the ICN identity. And what you see here in the message number 12, you might not be able to see from back, which is called a create session request, and this create session request will go with a PCOIE field being populated that I'm a ICN client and I would like to attach the network. So that goes to the gateway, and when the successful attachment is performed, that means the device is attached to the network, then the ICN identity will go back to the client. And when we have that, then in our opinion, this will be the native ICN attached to the network. There is no need to overlay, and then you can transfer the data. Either you can publish it or you can receive the data. So this is overall summary for this one. I have a draft going in progress, and Chair, thank you for allowing me to present today. But if any of you want to join in the draft, we would really welcome, because in our opinion, if we have a work done collaboratively, probably we'll be able to put forward and convince 3GPP. We have proposed to 3GPP, they're evaluating, but I think more industry support is required to really push for this. So if there is any question, I can just take it on that, or I'm available for rest of the day, and feel free to reach out to me.
So I had one question, because it wasn't clear to me, because I'm not a cellular expert at all. It was clear to me that in the first 2 deployment scenarios, you're still running a GTP tunnel all the way back to the packet core, right? So all the mobility stuff is still being handled by the standard cellular mobility, and whenever you move, your tunnel gets moved. So the ICN network doesn't get involved in mobility. The ICN protocols don't get involved in mobility at all, and you're basically, you're either running ICN over IP over a GTP tunnel, or ICN directly over a GTP tunnel. Those are the first 2. But I think that's correct, right?
That's the overlay scenario. But if you go to the, so this one
But then
was,
I wanted to look
yeah,
at the later one
yeah,
that I guess I don't quite understand, which is this one.
yeah.
So what's the data encapsulation here? I'm trying to figure out, are there native ICN messages going between the UE and the node, eNode B, and then the eNode B is ICN aware?
Yes, yes. eNode B is completely ICN aware. And it ties back to the question what Mr. Akbar was asking earlier about network slicing. In the 5G scenario, when the network slicing is being proposed, there are also discussions that can be used some of the other protocol other than the GTP to create the slices and to manage to send the traffic. So probably that be the case, then we may not need GTP. We will be able to use natively on that.
Okay, now I think I understand it. So what's the protocol that you're proposing from you have native ICN messages at the eNode B, and that would run on top of what?
So we don't have a proof of concept ready yet to demonstrate. We are working on this concept. Probably in a couple of months we'll be able to show, and then we can say that what protocol we'll be using in place of GTP.
Okay, thank you.
So Prakash, one question is that in 5G, there's a proposal for non-IP PDUs. So do you have any idea on how that is going to be used? Would that be a good vehicle for ICN, or is there any push for? I mean, that seems to be a more uh, kind of ideal point to insert ICN into the.
Yeah. Thank you. And basically, if I remember, in 3GPP release 13 was the first time when many of the industry folks pushed for known IP uh, packet data in the 3GPP, because until that time it was only IP. So in my opinion, the ICN could be the known IP, and there is a provision that the next gen network, 5G network, will support IP and known IP. So when we go to known IP, this is what ICN we can propose to them. But the only way we'll be able to propose is to put it inside the 3GPP protocol itself, because if you don't put it inside the protocol, then it will still be overlay.
The draft, I mean, the 3GPP, because I don't I think it would be difficult to do anything in the LTE space, right? I mean, if at all, any clean slate needs to, because with pricing, you can introduce new data frames, right? And so, I mean, so is there any push right now to do in 3GPP in the context of 5G with non-IP and ICN and termination and the node B and stuff?
See, from Cisco side, I know we have a smaller team to work in 3GPP now than what we used to have, but we are pushing for this known IP as a protocol for this transport part, and also for signaling plane.
Ms. Akbar. I really like this approach. It's very interesting. The one question that was not clear to me in your diagrams, when it finally gets to the edge, I guess the right hand edge of the core network, it then gets converted to like HTTP or some other existing IP protocols, or like, well, I guess the other way to phrase the question is, what do you assume about the other end outside of the cellular network?
See, in my opinion, in sometime in the future, right, it will be a native ICN or NDN based protocols. So especially for the data which doesn't have to be native IP. So if that be the case, then from cellular onward, you can just send it using the ICN based transport. But if that does not exist, then of course it has to overlay from there on the IP.
So you would have like some gateway or something translating.
So this gateway, if you look at it, which we described as a PDN gateway, the third from the right side, that itself will have the capability to understand that if the client is natively attached as an ICN, but the uplink transport is not ICN, then for that type of transport, it has to overlay. But if the uplink transport is ICN available, then don't overlay, just send it as it is.
Okay. But isn't there also a third option that, because the overlay, what I understand from your like sort of the context, is that you're overlaying ICN packets at the gateway to run over IP to the other end. But if the other end is like pure, like let's not call it legacy, but today's HTTP server, then it's not an overlay. Then you would have to translate, you would have to break it at the PDN gateway, convert it to HTTP over TCP over IP.
Yes, yes.
So that would be the third option, right?
Correct, yes, yeah.
Okay.
Yeah.
Okay.
Yeah.
Thank you very much.
Yeah, and I'm looking indeed for collaboration with the industry, because when we started propose this idea, it took us a while to socialize internally, and then we started working with the ITU. Ravi was there. We presented to the ITU. They liked it, but they're not the standard bodies. They just create the vision document. So now we started working with the 3GPP. So if we can work together and then kind of a propose, I think that will be the way to get it embedded right into this 3GPP protocols.
I'd like to discuss offline with you. Thank you.
Okay, thank you.
Okay, thank you. Then
Thank you, Chair.
very much. Then we're reaching lunch. By the way, you said you wanted to discuss offline. In general, we have this. We might have some breakout sessions at the end, so it's not defined exactly what they are going to be. So if people want to come up with something during the meeting here, you see that there are some people here that you would like to join together and work, talk a bit about that. That's an excellent opportunity to do that. And you can, of course, continue during the week, and then if you come up with something, a slide or two that you want to present at the Thursday meeting, you could certainly find time for that, for a quick thing to get. And please feel free to use the mailing list during the meeting now if you want to exchange ideas and things like that. So that's an opportunity that you can take. Okay, so we'll break for lunch here, and we'll be back at 2 o'clock for the next session.